I decided to go ahead and add another video with these general probability examples before we move on to the next section. So let's just take a look at some of these examples. Number one is pretty straightforward. You have an experiment where you're drawing a ball from a box that contains 9 balls numbered 1 through 9. So the sample space is just those numbers 1 through 9. And then it says, what's the probability associated with the outcome being an odd number? So basically, your event that you're looking for is the event of the ball being an odd number. And so if you look here, there's 1, 2, 3, 4, 5 ways this can occur out of 9. So the probability is simply 5 out of 9. Number 2 says a single card is selected a deck. Find the probability that a face card is selected. Well, there's 52 cards in a deck and there's 12 face cards. So the probability that a face card is selected would be 12 out of 15, which can be reduced to 3/13. A committee of 4 people is chosen from a group of 5 men and 6 women. What is the probability that the committee will consist of 2 men and 2 women? So over here I drew a little diagram where I show you the breakup of 5 men and 6 women. So there's a total of 11 people and you're going to select 4. So let's talk about the number in the sample space first. There's actually, you just have to figure out how many committees can be selected. So how many ways can you select 4 people out of 11? So that's going to be your denominator. There's that many ways to choose 4 people. And now from that, to get the probability, you have to put in the numerator the number of ways you can get 2 men and 2 women. Well, so out of the 5 men, you want to choose 2. And out of the 6 women, you want to choose 2. So your numerator would be 5 choose 2 times 6 choose 2. And then you can put it in a calculator and get the probability. Now, suppose your class has 50 students. You have 23 students majoring in psychology and 16 majoring in sociology. 7 students are majoring in both. If a student is randomly selected, what is the probability that you pick a student that A is majoring in psychology alone? Now what we might want to do here is draw a Venn diagram. So let me get a Venn diagram for you. Okay, so this is just a kind of a rough Venn diagram here. Out here I'm showing you that there's 50 total students in this rectangle. In the psychology circle we got 23 students. In the sociology circle we got 16. In the intersection we have 7. So that means that these 23 can be broken up into 7 that are also sociology majors, and then there's 16 that are just majoring in psychology. I just take 23 minus 7 to get 16. And then over here, if you take 16 minus 7, you get 9 that are just majoring in sociology. And then if you add these 3 numbers together, you'll see that the union contains 32. And if you subtract 32 from 50, you'll find that there's 18 that's majoring in neither. So from that table, we should be able to get our probabilities. So majoring in psychology alone, that would be these 16. So the probability would be 16 out of 50. In sociology alone would be 9, so that would be 9 out of 50. In either sociology or either psychology or sociology, well, that would be all 3 of these groups, so that would be 32 out of 50. And then neither psychology nor sociology, that would be these 18, so that would be 18 out of 50. And then not majoring in psychology, you've got to pick all of those that are not in psychology, so that would be these 9 plus these 18, and that would be 27 out of 50. So that would give you 27 out of 50. And then, of course, you can get decimal values if you need them. The next example is a little bit like number 3. You have a department store that has 27 portable radios, and there are 4 defective in the shipment. So basically, let me just kind of freehand this. So if we break up the shipment, you've got there's 27 total but 4 of them are defective, so I'll just write bad for defective. So there's 4 that are bad, and that means that there's 23 that are good. So basically you have, and you are going to select 6 for display here. So we're going to select 6. So your denominator is just going to be 27, choose 6, because that's the total number of samples you can have. And then it asks for the probability that you get 2 defective. Well, if you're getting a sample of 6, that means out of these 4, you want to choose 2. So 4, choose 2. But then you also got to get 4 bad ones out of the 23 good ones. I'm sorry, 4 good ones out of the 23 good ones. So to get 2 defective ones, you got to have 2 defective and 4 good ones. So out of the 4 defective, we choose 2, and out of the 23 good ones, we choose 4. And then you put this in your calculator, and you get 0.1795. 6 is another one similar. It says 8 cards are drawn from a deck of 52 cards. So basically, you can draw a rectangle here. You got 52 cards. You're going to select 8 cards, and it says, what is the probability that you get 4 face cards and 4 non-face cards? Well, there's 12 face cards in a deck, and that means there's 40 non-face cards in the deck. Okay, now your denominator would simply be 52, choose 8. That would be the total number of 8 card hands. And then your numerator, you want to get 4 out of this 12 and 4 out of this 40. So it would be 12, choose 4, times 40, choose 4 for your numerator. And then you just figure that out on the calculator to get the decimal value. You can draw the picture for this one too if you like, but by now hopefully you kind of get the idea. You're going to draw 5 cards from a standard deck. So the numerator would be 52, choose 5. And then you want to know the probability that they're exactly 3 hearts. Well, since it's a 5 card hand, that means out of the 13 hearts, you've got to choose 3. And then out of the 39 cards that are not hearts, you have to choose 2. So multiply that together and divide by the denominator, and you get 0.0815. Now this one says you have a committee of 6 people chosen from 6 men and 5 women. It says, what is the probability that the committee will consist of at least 4 men? Now, at least 4 men in this example means 4 men or 5 men or 6 men, because you can get up to 6 men. So what we have to do is we have to find the number of ways to get 4 men. So that would be 6 choose 4 times 5 choose 2. So that'd be 4 men and 2 women. So that's 150. And then we got to find the number of ways to get exactly 5 men. So that'd be out of 6 men choose 5 and times 5 women choose 1. That's 30. And then the number of ways to get exactly 6 men. Well, that's just 6 men choose 6, and out of the 5 women choose none. So that's 1. So you've got 150 plus 30 plus 1. So you've got 181 possible ways that you can get at least 4 men. And then, of course, your numerator, the number in the sample, your denominator, the number in the sample space, is just out of 11 people, how many ways can you choose 6? So it's 181 out of 462, which is 0.3918. Here's another poll problem. Basically, we have 500 voters in different parts of the city, and this many favor something, and this many oppose it, and this many had no opinion. So we want to find the probability of having, we're looking for the probability of no opinion or living in the inner city. Well, no opinion would be a total of 200. Inner city would be a total of 245. But that includes the 85 twice. So what you have to do is add 200 plus 245, then subtract off the 85. And you get 360 out of 500, which is 0.72. B says being in favor of the issue. Well, that's easy. You just count how many are in favor. So that's 150 out of 500, which is 0.3. And then C says being in favor and living in the east side. Well, that would just be these 30, because that's the intersection of being in favor and the east side. So that'd be 30 out of 500, which is 0.06. And then the last one says not being in favor. So not being in favor, you just figure out how many were in favor and then subtract it from 500, and you see there's 350 that were not in favor. Now, not in favor doesn't necessarily mean it opposed. It means that they didn't vote in favor. So there's 350 that didn't vote in favor. Okay. All right. Here's a couple of challenge questions that you can think about. In poker, let's say you want to find the probability of getting a full house. Well, think of that would be 3 of one number and 2 of another, like 3 kings and 2 fours. Well, let's think of 4 operations. The first operation would be getting the first kind. In other words, the kind that you're going to get 3 of. Well, there's 13 kinds. Ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, Jack, Queen, King. So that's 13 kinds. And now, out of those kinds, how many ways can you get 3 of them out of 4? So, it doesn't really matter what we're talking about, but let's say you want to get 3 kings. So, how many ways can you get 3 kings out of 4? Well, that would be 4 choose 3, which is 4. Then, you want to get the second kind. Well, your second kind can't be the same as the first kind, so that only leaves you 12 kinds to get 2 of. And then you want to ask, well, how many ways can I get 2 cards out of those 4? So, for instance, maybe we got 3 kings and 2 queens. So, out of the 4 queens, how many ways can you get 2 of them? And that's 6. And then what you do is you multiply each of these operations together, and that tells you how many ways you can get a full house. That's how many possible full houses are in a deck. And then you divide that by 52 choose 5, the total number of hands, and that gives you the probability. In Texas Lotto, you choose 6 numbers from 1 to 54, and the order doesn't matter, and you cannot have repetition. So basically, to win the jackpot, you've got to match all 6 numbers. Well, there's only one way that you can match all 6 numbers. There's only one winning combination. But if you think about it, how many 6-number combinations are there? Well, since order doesn't matter, we're just doing a combination. So that would be out of 54, choose 6. You'll find that that's close to 25 million. So you can do this on your own if you want to. Roulette contains the numbers 0, 0, 0, 1 through 36. So you can read the rest of that. But if you bet on red, what's the probability of winning? Well, there's 18 ways to hit red out of 38 total slots. So that would be 9 out of 19. If you bet on green, what's your probability of winning? Well, there's 2 ways out of 13 to land on green. So that's 2 out of 38 or 1/19. And if you bet on the number 7, well, there's only 1 7 out of 38, so that probability is 1 out of 38. Go ahead and read the rest of this, and I'll just explain it here. This says, if you roll a pair of dice, what's the probabilities you win on the first roll? Well, there's 8 ways to roll a 7 or 11, so that would be 8 out of 36. What's the probability you lose on the first roll? Well, there's 4 ways to lose on the first roll. You roll a 2, 3, or 12. There's 4 ways that can happen out of 36. So that's 1/9. And then what's the probability that you continue after the first roll? Well, you take the 4 ways you can lose, the 8 ways you can win, that's 12. Subtract it from 36, and that leaves you 24 ways that you can continue after the first roll. So hopefully that gave you a good idea on how to calculate probabilities for experiments and games and things of that nature.